Dad, what's the future gonna look like?
Good morning, good afternoon. I think we just crossed the noon point. Appreciate you all hanging in with us. Thank you, Cyrus. Thank you to the Walton and Pro families for having me here today. Delighted to talk to you about the company, some of the things we're doing. What we'll kind of walk through here is I'll tell you just a little bit about the company. Then I'll tell you a little bit. We'll geek out with some hypersonic and space-based technologies. We'll show some videos on that. And then I'll kind of finish up with talking about why that matters, why that should matter to you, why that should matter to all of us, and the geopolitical situation that attaches itself to. So first off, just kind of, before I get rolling, a special shout out to the Pro family. When I was a midshipman, H. Ross Perot came to the Academy a few times while I was there and was a huge benefit factor of that institution. And that inspired me because I'm an industrialist. I'm a defense tech industrialist. I build things, I make things work, I make things go faster, I make things more cost effective. I make my investors money by doing that. That's why I'm really excited about the story we've got here at Ursa Major. So we are building the world's next great aerospace and defense company around a core of propulsion, and we'll rapidly expand up into other avenues as well. We'll talk about some of that propulsion today, but we're also now building our all-up missile rounds, and we're moving up into space-based applications. So we're focused very heavily on 3 areas. Those 3 areas are critical for national defense, security, and deterrence right now. That's hypersonics. Hypersonic means more than Mach 5. More than Mach 5 at sea level means more than 3,800 miles an hour. More than 3,800 miles an hour means New York to LA in an hour, or as the Chinese would say, from Xinjiang to Guam in 38 minutes. We're working on critical rocket motor technologies, and we're using advanced techniques in additive manufacturing and agile platforms to do that. And we're getting extended range out of current munition systems. So if you have a helicopter and you have to launch something from that helicopter, and you've got an extra 40% of range on the same thing that you can deploy, that means you get to stand 40% further back and hit your opponent with more mass, faster, and a survivable platform. So we'll talk about cost, survivability. And the third thing we're working is in-space applications. It's a critical area of national security for the Space Force to do sustainable space mobility. And that means across wide ranges with enough what we call delta V, or speed and acceleration to get there in a time in which it matters. So we're not talking like really, really low speed solar electric propulsion on interplanetary type exploration missions. We're talking that the Chinese are doing something, they're sending something up into geo, and we want to get there and we want to be there before they are. So we're working space-based mobility. Turns out those space-based mobility applications that we have are also really good for high-speed interceptors, including space-based ones. And we just signed a $35 million deal to work on the first Golden Dome applications in that area. All right, this is Paul Allen's former plane. These are our partners, Stratolaunch. And before I run the tape, I kind of want to explain to you what you should be looking at here, what you should be watching to see. So this is a big, kind of funny looking plane. The guys I've talked about in the trainer, when they take this out on the runway, you sit on one side, they run the wings into stuff on the ground because it's a massive plane. But underneath this plane, there's kind of see it here, it's a Talon A vehicle. While this plane's flying, it's about 30,000 feet. That vehicle is going to drop off the plane. It's going to go through an entire launch sequence. The propulsion technology is powered by Ursa Major. So you're going to go through an entire countdown while you're falling, and you're going to see this thing take off. That engine is about this tall, about that big around, and creates 5,000 pounds thrust. It's about 80% 3D manufactured at our Manufacturing Center of Excellence in Youngstown, Ohio. When it does that, what you're going to watch for next, you'll watch the ignition. Then you'll see, it flies for about 4 minutes. We don't have 4 minutes of video because this thing goes over Mach 5. You'll see it in one of its flight sequences up above the limb of the Earth, traveling in excess of Mach 5. And then you'll see the engine cut out, as it was designed to do. You'll see the extreme speed, and then you'll see the vehicle land. 100% autonomous, hypersonic flight. Now, we've done this 5 times. We're 5 for 5. We just did our last one Saturday, and we're doing this test about twice a month right now. Why that's critical? The Chinese and the Russians have stuff that we can't even test against yet. We can't see if our satellites work against it. We don't know if our command and control works against it. So just having targets and test beds is a great start. We've cracked the code on economics for that, and that's about what you're to see here. So we'll walk through that. Again, we just did this again last Saturday, 5th time in a row.
22 through 50.
5, 4, 3.
Release. Good release. Good release. Good ignition. Good ignition.
Right there.
Right up you must. Wow. Test control. Talon's at 104,000 feet. Mach 5 point on condition. Test control. Talon is MECO nominal. Test control. Talon's 0.3 nautical miles away from the runway. Test control. Gear has deployed. Test control. Talon's touchdown. Test control. Talon has landed.
That's the first time in the history of the world a vehicle's flown endo-atmospheric hypersonic speeds and landed. You just watched it there. Now, we've been experimenting. We're testing all the time. We've got a 90-acre campus up in Berthoud, Colorado. That's the Hadley engine. That's what was flying that thing. That's the first engine we built. You know, we blow a lot of stuff up. We're testing anywhere from half a dozen to dozens of times a week on our different test stands. It's not like we showed you success there. This is not success. It's over 5,000 degrees in that chamber. The rotating machinery, which is also 3D printed, is going about 55,000 RPM. When things go bad with rocket technology, they can go bad really quick. So we developed this engine, and the Air Force came to us and said, you know, that's a really cool propulsion pack, but it's not tactical. We said, what do you mean by tactical? They said, we would like it to be smaller. We'd like it to be 13 inches in diameter so it could fit inside current configurations like a Tomahawk missile. We would like it to be storable, including up in space for up to 10 years. And we'd like to push a button, not have any cryogenics involved, and watch this thing take off and have similar performance characteristics. So about 2.5 years ago, the Air Force paid us to develop, get it here? Draper. That's the first technology, that's the second technology. Now, Draper is a magical piece of technology. It is about 60% of the part count of Hadley. It's also about 70% 3D printed. It develops a similar performance characteristic, but it's throttleable. You can turn it on and turn it off with a push of a button. When you turn it off, you can turn it back on. When we watch that Hadley flight, if you don't get ignition with a cryogenic system, it goes in the water. With Draper, you can keep trying it. You can refuel it, you can reuse it, or you can use it for a single-use application like a hypersonic. Draper is the future of aerospace, the future of hypersonics, and because it works exo or endo-atmospheric, so outside the atmosphere or inside the atmosphere, it's also an ideal space-based interceptor or sustained space mobility platform. It is 100% American-made. It is advanced technology, and it's rolling off the line in economic numbers. We can build about one of those a week right now. There's some of the specs. Uses hydrogen peroxide and kerosene, RP1. So what are we going to do with that? Here's a test. We've got about 250 tests on the stand. We're working to fly that before the end of the year with the Air Force. We went under contract in April, and we'll fly in December. So, you know, kind of back to World War II type programs where we can move really fast. 4,000 pounds thrust, no cryogenics, no venting, nothing. Push a button, cat bed, and you get start. This is a beautiful, beautiful piece of technology. I talked about having something that's economical. Why does economic matter? As we think about the threats in the world, we talk about 6th-gen technologies. They're not somewhere over the horizon. The Chinese and the Russians have deployed 6th-gen hypersonic technologies, and we have not. They're a handful of years ahead of us, and we're working really, really hard and fast to want to catch up. This is the thing that's going to allow us to catch up very quickly here. You can't only have an exquisite technology that costs tens of millions of dollars every time you want to do something. Quantity is its own quality. It's very important to the strategic planners, the Air Force, the Space Force, the Army, the Navy, and we're under contract with all of them right now, to be able to have something that they have lots of. Magazine depth matters. The number of shots you get matters. How much those shots cost matters. That creates strategic deterrence. The more places you can have those, the more deterrence you create. My team's getting t-shirts printed up that say, "Not today, President Xi." We want that level of deterrence, that they're not crossing the straits, not on our watch. We're working really hard to bring that technology out into the field. So, this is artist renditioning, but this just left my factory floor. It's out on the test stands, and it's getting ready to get shipped down to my friends from New Mexico. White Sands range, yes, Wismar. We'll be flying at Wismar in December, pending government shutdowns and range time. We're going to do our first supersonic flight in 2025. We'll do a hypersonic flight, including a flight out in the Pacific in 2026. We want to have a range of over 500 nautical miles when we do that, and we want to show the Chinese that we've got something they didn't know we have. And then we're going to do that off Norway. We're going to show the Russians we have something they didn't know we have, and we're going to create, even at those initial stages, an extra level of deterrence. And by late 26 and early 27, we'll be doing tests of that vehicle and that configuration in space. Space-based interceptors. There's a really nice pod out there. I was looking at the habitability of it, and I was thinking how nice it would be to have a few of these up there for deterrence inside that. So the Chinese are ahead of us. Somebody asked me, are the Chinese and the Russians ahead? They are ahead. No doubts about it. They've fielded systems that are able to kill ships in cruise missile formats. They're survivable, and they can keep us out of the Pacific region if we don't respond quickly to their threats. They've also got an awful lot of them, so they can overwhelm us with mass if we don't catch up quickly here. Why is that important? Well, I spent a lot of my time out in the Pacific. I spent a lot of my time out in Pearl Harbor. The last time we went to war with an adversary that had better technology than we did was World War II. Zeros were better airplanes. And we got pushed all the way back to Australia. We don't want that to happen. We're using very expensive munitions in large quantities. Ukraine has shown us that. The war in the Middle East has shown us that. We have expended over 700 Navy Standard missiles. We've expended over 100 THAAD missiles, some of which are millions and millions of dollars each. We need the price poised down on those, and we need to be able to arm the fleet. We can't have our fleet only have armaments for 3 days to 3 weeks is what the current estimates are. So we're going to solve that. The last time we went to war with an adversary that had better technology than we did and a better industrial base, so larger manufacturing capabilities, was the War of 1812. And they burned our nation's capital. We don't want to let that stuff happen. We don't want to let it happen in the Pacific. And that's why we're here with Ursa Major to help solve those problems. Thank you for your time.
The future is gonna be awesome.